Hello, Math 133 students. I received a question about this problem, which is 3.4.9. So if you were in the textbook, it would be number 9 on the exercises as well as the study plan. So if you look at the study plan, which is available under Student Resources, you can actually see lots of questions. Some of these have been assigned as homework for points over in the homework portion, and some are not. So if ever you want extra practice, this is a place you can go. All right, so I'm going to click on View an Example, and I'm going to go over the example, and in so doing, you will see how to do the problem. All right, so 1 year Larry had the lowest ERA, earned run average, mean number of runs yielded per 9 innings pitched of any male pitcher in his school with an ERA of 2.98. Also, Vanessa had the lowest ERA of any female pitcher at the school. Of 3.44. For the males, the mean ERA was 4.221 and the standard deviation was 0.898. For the females, the mean ERA was 5.325 and the standard deviation was 0.799. So we're supposed to find their respective z-scores and which one was the better relative to their peers. All right, so let me pull up a Word document really quickly. All right, we'll start off with we want to know Larry's z-score. So that's the first one we're going to find. So the z-score formula, and it's given to you right here in the document, you can see it's x minus mu divided by sigma, or it's x minus x bar divided by s if this was a sample versus a population. So they're treating this as if it's the population of all these students for that year. All right, so if z equals x minus mu divided by sigma, x is the particular student's value, and then let me see here. X is the student value, mu is the mean for that population, for that group, and sigma is the standard deviation for that group. So z equals x minus mu over sigma. Now the thing is that Larry's score was, and actually I'm going to give this a little subscript. I'm going to say this is for Larry. So I'm going to give a little L here. So the x for Larry, the mean for Larry, the mean for all the it looks like the male players, and then the standard deviation for all the male players. So everything is relating to Larry. So that would be Larry's score, which was 2.98 minus the mean, which is 4.221, over the standard deviation, which was 0.898. Now, the mistake students make when they go to type this is they'll type it incorrectly in the calculator. So let me show you the calculator real quickly. So what you want to do is you want to make sure that you type it in such a way that it'll take the numerator and do it first and then divide it by that denominator. So let me clear this out. So you want it to group together that numerator. That numerator, that division bar in the middle is actually a grouping symbol. It's like parentheses. So you have to put it in parentheses, that numerator, and divide it by the denominator. So you close out the parentheses for the numerator and then divide. Now, if you have a TI-84 and it's upgraded, then you can actually use a different system, which is called Pretty Print. So you can hit Alpha F1. See the F1, which is in green. So you hit the green key and then hit Y equals. And it's giving you a fraction menu. FRAC stands for fraction. And you can say, I want number 1, which is N over D, numerator divided by denominator. So I say number 1, and it makes a fraction symbol, just like it looks like on the formula. So you can say I want 2.98 minus 4.221, and then to move down, you have to kind of arrow down with your arrow key. It's a little bit more like, almost like a computer. And you type 0.898, and you press enter, and that will also work. So either method, either put parentheses around the numerator or use the Pretty Print, which is under Alpha F1. TI-83s do not have that option. 84s do, as long as they're newer or have been upgraded to the newest operating systems. Remember that you can update those operating systems for free, either in the Center for Student Success or by connecting your computer up to your calculator and going to the TI website, and you can look for it there. All right, so this would be negative 1.382, roughly. So negative 1.382. That should be the z-score for this individual as far as I am concerned. There we go. the wrong button there. Now let's see if the computer agrees with me. So I click continue, I can go through, it's going through the formula. There it is, negative 1.38. Great. And then you just do the same thing for Vanessa. So for Vanessa, we're going to, I'm just going to copy and paste here and then change it all to Vanessa. So V for Vanessa. Vanessa z-score. All right, so let me pull this up. So this will be for Vanessa, so I'm going to change these. So the z-score for Vanessa is Vanessa's score divided by the mean for Vanessa, which is the mean for the females, and the standard deviation. So her score was, let's see, Vanessa was 3.44. So I'm going to change this to 3.44. And then this mean was 5.325. And the standard deviation was 0.799. So a little bit smaller in the standard deviation. If I could get down here. All right, so I'll grab the computer again, or the calculator. And then let's see here. I'm going to take parentheses 3.44 minus 5.325, close parentheses, divided by 0.799. Enter. Or put another way, alpha F1, number 1, 3.44 minus 5.325. Use the arrow key to arrow down, and then 0.799. Enter. So either way, we get negative 2.36 if you round it to 2 decimal places, which must be how they want it to round because they're telling us right there. So 2.36. And there we have it. So if I click continue, we should see, yep, negative 2.36. Now they want to know who, which player had a better year relative to their peers. Okay, well, in baseball, you want to score, right? So let's see here. So Larry's z-score had, oh, they're both negative, that's true. So the player with a smaller z-score did better relative to their peers than the player with larger. So had the lowest ERA. Oh, this is a bad thing. So you want earned run average. You want runs yielded per 9 innings pitched, right? So if you want, oh, and they say it right here. Note, in general, the lower the ERA, the better the pitcher. Well, there we go. Oh, right, because the other team wants the runs. You, as the pitcher, don't want the runs. There you go. So you want the other team to fail, essentially. So if this is the pitcher, right, on average, right, this is how many runs he's letting in per 9 innings. So for every 9 innings, Larry's letting in 2.98, but the average is 4.221. So his z-score is negative, right? Because these are both good pitchers. That's why they're both negative. If they were positive, these people probably wouldn't be pitching anymore, right? Okay, so Vanessa is letting in 3.44 runs per 9 innings, right? But compared to her peers, that's lower. So who's doing better is actually Vanessa. She's letting in less pitches relative to her peers than Larry is, right? In general, for a pitcher, the ERA score being lower is better. So Vanessa is better because her z-score is lower. And lower ERA is a good thing. For our pitchers, right? Because it's the earned runs. It's how many runs the opposing team is making off of you when you're the pitcher. All right, I hope that helps.